anyway, regarding to the midterm exam sheet, so we will check on the Thursday. Those who want to check your exam sheet from the online course will can attend the next class. Okay. I think we need to complete the deadlock detection algorithm, which is almost the same as the Banker's algorithm and the deadlock avoidance. So we will quickly check such algorithm. So detecting algorithm, the idea of the deadlock, there are three ways of how to manage the deadlock. Okay, the first one is deadlock prevention. How to prevent the deadlock? You can actually break one of the requirements of the deadlock situation. So what is the deadlock? What is the full requirement of the deadlock? The first one is mutual exclusion. It should be shared, right? So if it can be shareable, everybody can use that resource, then there might be no problem. So if you allow the shareable resource, then you can prevent the deadlock. So another one is hold and wait. So when a processor is holding the resource and request, if you are not holding any resource, there might be no problem. So which means you can make the sequence of the, when you use the resource, then next one take. So you can break one of these. The third one is, what was the third one? Mutual exclusion, hold and wait. The last one is circular wait, right? And what was the third one? Let's see. No preemption, which means you cannot back up. Okay, so in case you allow the back of the stop, the process and restart, then there might be no problem for the deadlock, right? So you can prevent the deadlock by breaking one of these requirements. That is the deadlock prevention. Deadlock avoidance means it's quite similar, but if you receive the request of the resource in terms of the operating system allocator. One of the main job of the operating system is to coordinate and manage such a resource for the multiple processes. If you receive the request, you need to check whether this request cause the deadlock situation or not. How can we check? At the time we can use resource allocation graph. Okay, in the resource allocation graph, if you can find the circular way, then that's not always. It's not if and only if, okay? That's not always cause the deadlock, but it may cause the deadlock. So you are not going to allow such a request. Then how can you find such a thing? At the time we can consider if we can find the process list in case of the multiple resource. So we apply the Banker's algorithm. So we can use the allocation max and need. Need means max minus allocation, then available. Using this information, if you can find any sequence of process that can be completed, then it's in the safe state and allow such a request. So there might be no problem on the deadlock. So that is the deadlock avoidance. First, this approach never enter the deadlock situation. The third one is you can allow actually any request, whether or not that cause the deadlock. Okay, but periodically operating system check whether current status is in the deadlock or not. How? At the time you can use the same approach as the resource the Banker's algorithm with the resource allocation graph, which means whether you can find the circular way. In other words, whether you can find safe state sequence of the processor that can be completed. Okay, so at that time we can use the same the information available, allocation, and request. Okay. So it's basically the same idea. So for example, suppose that we have the three different types of resources, A, B, C. A we can consider as, for example, hard disk drive. The B is a semaphore. C is something, the memory. So something like that. So we have the the instances, 7 available, the resource A, and similarly 2 instances for B and 6 instances for C. So multiple instances cases, then the currently, this is a current situation. Okay? That's a different thing from the deadlock avoidance. Avoidance is before enter the deadlock situation. So if I allow this request check whether there exists circular way 1. Okay? So in this case, this is current status of your process and the resource. So at the time we have the 5 processes. For example, processor 0 is currently holding the 1 instance of B, resource B. Then in the future, it requests the nothing. Okay, so it's currently just holding 1 user. And the B, P1, which means the P0 will be eventually completed, right? Because it doesn't need any other, so it's currently holding. Then current state, it may not. The processor 0 does not cause any problem. P1 is holding the 2A, and also it requests, currently the P1 is requesting 2 over A and 2 over C. Okay, something like that. It's waiting. Okay, so which means the P2 is also holding 3 over A, 3 over C, and not requesting, which means if P0 and P2 will be eventually completed. Even though we do not have the available resource, but eventually there might be available resource. At least 3A, 1B, and 3C. Right? Then P0, P2 may not cause any problem. Then such available the resource will be allocated for the any of these. Then eventually all process will be terminated. Which means, that's it. Is it the deadlock situation or not? No. It's a safe state. So which means there might be no problem. You don't have to worry about that. Move to the next state, However, so for example, what about the only P2 is completed? Yes, P2 is completed and P0 may not. Then you can use a 3A, 3C only. Then at the time P1 will be completed and something like that. So you can find a different order, but at least if you can find one of them, so it may not cause the deadlock situation. However, P2 requests additional instance of the type C P2. It's actually the previous state. There was no problem in deadlock situation, but in the next state, so as I said, deadlock this is a deadlock detection. Okay, so you actually allow any request, but periodically check whether there exists deadlock or not. This is the next state. During that time, the P2 requests the C before terminating. Okay, so that is the only different thing from this one. Okay, P2 has 1 more C. So you allow, because this is not prevent, this is not avoidance. So using this one, P0 will be eventually completed. So we are going to use this one. P0 will be completed. Then still there is no available C, right? So this one may be completed 2, 1, 1. Let's see, are there any difference? So this is a requesting, there is no available, okay? P0 can be completed, right? So we have 0, 1, 0 available. 0, 1, 0 available. Using 0, 1, 0 available, you cannot terminate any of this process, right? Because we need at least one C over here. But only P1B is available, which means we cannot find any sequence of a process right now that all of them can be terminated, right? Which means it is not deadlock, it may be deadlock, okay? So we need to do something. How can we solve the problem? We are going to find one of the process that can be terminate. Not terminate, it's the ending portion. Okay, we kill the process. Sometimes it can be multiple processes. Sometimes it can be all the processes. Depending on the post operating system policy, you can consider some of the priority or the previous history. You can find the best way to decide the victim process or processes. So, but anyway, when you select the victim, it should minimize the total cost. However, you need to consider the salvation problem because sometimes there might be certain process or the processes that can be always a victim. If you just consider the priority, if there exists the process with the lowest priority, it can be victim every time. So you need to consider such a thing. Okay, like the A thing. In the practical operating system, they usually consider all of this mostly ignore such a detection. Why? So such a banker's algorithm or the detection algorithm, their computational complexity is actually n square n which means number of research and number of process, but you need to check 2 times of for each. Okay? So n times n squared is very complex. It's almost a brute force way. Okay? So which means that doesn't mean it's a high number, but it's not linearly increase, it's exponentially increase times n. So you cannot guarantee the optimized one. In other words, this is a very, very complex algorithm. So if you apply this one, it's usually, in general, the most of the graph, the operation are NP complete. As we discussed, NP complete is not optimized one. It's most complete. In other words, it takes a time, but not just it takes a time, it's complex. Okay, not optimized. So the practical implementation, we ignore such a detection. Who is in charge of that? The user. Okay, and the user will be in charge of to handle such a deadlock situation. Mostly, you kill the process, right, and restart the computer sometimes. Okay, that is chapter 7. So we will skip. Right now, I'm going to change the order of the chapter that we are going to cover. So, skip 8, 9. Those are for the memory management. So we will discuss the memory management after we complete the file system. File management. Okay, so because we have the second project, as you have seen in the freelancer.com, how much you wanna pay if somebody want to do your project? $100? No? I think that it was because I didn't teach the operating system for a while, so 3 or 4 years ago. At that time, the couple of students tried to do the same thing. They said that they paid the $35 for the implementation. Even actually the guy said the same code to the 2 students, and then informed me. Then they submitted. It's exactly same code. So they paid $35, so total of $70. Okay, so we jump to the chapter 10 for the second project. In second project, you are going to implement the portable file system. What was the file system? It's a data structure, yes. For what? For file management, right? So, which means that is a software. You can implement the data structure. Data structure, why do we need the data structure? Actually, eventually we implement the program. Then you can, through that data structure, you can order, ask, command to what? Computer. So in this case, you can implement, after you understand the data structure, then you can implement the software, which is the file system, just like NFS files, the Unix file system, NTFS file system, the ext2, ext4, 6, what else? FAT 16, 32, and all of these are file system software. It's a data structure to handle, to manage the file. Okay? Which means in your second project, you can implement portable file system. That means that will run on operating system, your file system, your operating system. Okay? Then what's the requirement? Requirement will be based on that we are going to cover the next 2 or 3 chapters. It's already mentioned in your project description, but nowadays, how many of you heard about the big data system? So big data system is basically based on what? File distributed file system. That is the idea of the big data system, because the single centralized system cannot handle big data. So we do, this is a simple idea, why don't we have the multiple? There exists the software, such a distributed the system or parallel system. It was very tough and hard, and even programming is more difficult. So Hadoop was the Apache Foundation project. They developed HDFS, Hadoop distributed file system, as well as the programming, parallel program, MapReduce, which is called the MapReduce program. Actually, both of them are from Google. So the HDFS is kind of, the Google file system is kind of the parents or grandparents of the HDFS. Then what is the HDFS? It's a file system. It's a software to manage the big data. It's the same thing. Then when you install the big data system, Hadoop system, it actually install the program running on your file system. Okay? You can install the HDFS on your MacBook or the Windows or Linux. It's running on existing one. In your project, it's the same thing. You can implement the simple file system. Okay? That is running on your existing operating. Because the reason why I'm explaining about such a idea is some of the, I know still there are many students who are confusing. How can I implement? How can I make the file system? Okay? It's just nothing but program. It's the same program as that you implement in your the Java programming course or the .NET programming course. It's the same thing. Well, different object for what? Manage the file, which means you can, in the file system like the macOS or the whatever, then you can import or the get or the upload the file in your portable file system, just like what the HDFS big data system is doing. When you install the HDFS, you have the command like the upload the file to the big data system or download the file. Okay, similarly, you can do that. We will discuss about such a data structure the next few chapters. Okay. The first chapter 10 is a mass storage system. We'd like to see the introduction of such a storage system in this chapter. It's not very complicated. It has several important algorithms. So overview of the mass storage structure. So we have the storage. Which one is the first storage that CPU can access? The data. Register. So in the CPU we have the register. Register is also storage. Okay, fast storage, but it's small, and the CPU can actually use such. I think in your microprocessor class or the embedded system class you learned about that. Yes, at that time we can use the machine language or assembly language to manipulate such a data. However, this data, where this data came from, is in the memory. Why?
It's fast.
It's actually we are going to discuss about the mass storage system, the file system. We have the file system, as you know, the to store the data, but it's slow. We will see how much is slow. Okay, the next few slides. So instead, we try to keep such a data as based on the cache algorithm. That is the memory. Also, even this memory is not fast enough compared to the speed of CPU. So we have what?
Cache.
What kind of cache? L2 cache. So L2 cache is the memory, even so 4 megabyte, 2 megabyte, or 4 megabyte. It's not that big, but comparing to the register, it takes a time. So why don't we keep such a data cache of cache? Okay, in the processor. So it's called the L2 cache. So when you buy a new computer or a new laptop, so you will see the mostly whether this is a dual core, how many core. Also, you need to check the cache size in the processor. L2 cache, the 4 megabyte is in general, right? The 4 megabyte. So it was 2 megabyte, but nowadays bigger is better. Not always, okay? Because it's more complicated in memory. So then memory. So finally, this is a file system. Then benefit, so cheap, so big. Problem, slow. So we will see such a part. Okay. Next few chapters. So this is the hardware mechanism of the disk drive. So this drive consists of stack of disk, right? So disk is rotating. So if you, how many of you open your hard disk drive? So what can you see in the hard disk? Just like that. Not like the thing is the yes. As you know, this much thin, the inchy, the width. Then you can see the set of the disk is just like your CD, right? So CD like then it's rotating with the spindle. So how fast is that? It determines the performance of your hard disk drive. So it's made by the RPM. Rotate. Where can you see the RPM? Your car. So engine RPM. So you can see the speed meter as well as RPM. RPM is how fast your engine is rotating, how many times per minute. So usually it's measured for the speed of rotation. So it's the same thing. The faster, the more rotate, the faster, right? So you can get the data, the faster. So rotating. Also, as you can see, this is called the cylinder. So it will be. Each disk has many cylinders. Okay. So how can you find such a location? You need to have the disk head. Okay, disk head is on top of the disk, bottom of the beneath the disk arm. So disk arm is moving forward and backward. So the two mechanisms, one is rotation, then another one is moving forward and backward. Then you can finally find the data that can be represented by cylinder number as well as sector number. So when you buy the hard disk drive, you can see what is the RPM, how many cylinder, how many sector. Okay? So using that information, however, you are not going to use the cylinder number or sector number when you search the data, when you get to read the data. How can you read the data in your program? You have logical name, right? Just like the bridgeport.edu. So you are not using the IP number when you access the web page or the server, right? So it's the same thing. So you don't know, you don't have to worry about. But anyway, to find the exact location of the data, you should know the cylinder number, track number, sector number, such a low level, the address information. But in your program, you can just use integer I, okay, or file name. Then it will be converted to the row level address. Then the disk controller knows such a row level address. Then the disk controller order to get such a data. Okay, but it takes a time. That is called the latency. So latency, the less latency is better performance in the that's critical measurement of the performance of the hard disk drive. So that is the magnetic disk. And this hard disk drive is connected to where? I/O bus. Okay, there are different types of I/O bus. Okay, nowadays even the fiber FC fiber channel and the SCSI and iSCSI are popular. So also you are using the fire. Nowadays not much a fire wire. Okay. So average latency is it's not linear, right? Linearly increase, but pretty much. So what is the current? If you buy the 1 terabyte, the hard disk drive, with the $100, what is the user RPM nowadays? I think the 7,200, right? Everybody believe, many of them believe the higher the better. Not always. It consumes the more the energy, and you cannot get such a full benefit. But based on the benchmark in past, this is the by millisecond. This is the average latency time by the RPM, cylinder RPM. However, the delay of the time total, the performance of your overall computer operating system is not just this may not cause any bottleneck. So you cannot see the bottleneck of your I/O from the others. So like the garbage processor or some others. Anyway, so you can define such a latency, access latency as the average access time. That makes sense. The average access time is consisting of the seek time. You should know which cylinder is rotated at which cylinder, okay, moving forward and backward, and latency, rotation latency, okay, and also, so total I/O time is such a latent access average access time, that is the seek time plus the latency, then amount of the data based on the different transfer rate. Transfer rate is so your I/O burst speed and the like that. And controller overhead is how long it takes a controller convert the logical address to the physical address. then when they got the data, how it takes to enter to the CPU, such a delay time overhead. So you can sum up such a thing. So you can. So this is the example of to transfer 4K byte for the 7200 RPM with you can just sum up 5 milliseconds, and this is from the previous benchmarking tester 7200 RPM. It has the 4.17 the millisecond latency. Okay, so this is the controller overhead, and transfer time can be calculated by adjusting the unit. Okay, this is nothing but the adjust the unit. So it will be in terms of millisecond, 0.031. Then you can sum up such a. It was a long time ago. The hard disk drive is such a huge. So even when I probably mentioned about my experience when we purchased the 32 gigabyte the EMC storage box. So it's a 32. Total is a 64 gigabyte, but it's a mirror automatically, so we can use the 32 gigabyte. So such a 32 gigabyte is 10 times of my salary at the time. So we purchased it in 1997. So it's just like that. We actually went to the airport in Korea, and it's directly shipped from the United States, like that. Then we deliver using the logistic company. So then it's not just the 32 gigabyte, but it was one of the biggest storage box at the time in the Korea. And nowadays there's a solid state disk, which means the idea is that the main difference between the memory and the hard disk drive is what? It's the volatile, it's non-volatile, which means if you do not have the power on the memory, you may lose such a data. But this one is slower, so what? Because it has the hardware mechanism, the SIG and the average latency. So why don't we use without such a hardware mechanism, without the rotating and the forward, backward, so we keep the similar memory structure, but the non-volatile, that is a solid state disk. Okay, it's much reliable than the hard disk drive, and problem is it's expensive. So nowadays for such a SSD is used for the critical system like the cell phone, okay, or in the real operating system or the computer hardware like the database system. We can use such a SSD for the mission critical the information. If that is frequently accessed, we can use such expensive. Even some of the company would like to use the memory with the backup the UPS system. Okay, UPS means unstopped power supply, right?
Uninterrupted power.
Yes. So with the UPS system, you can actually replace the part of the hard disk drive, the database, the file with the memory. First, this data. Okay. But much faster and much smaller because it does not have the hardware mechanism. So because of that, we use the SD card in the cell phone. What about the magnetic tape? Have you ever used the magnetic tape in your computer? My first personal computer was the IBM XT 1983 when I was the 7th grade, 6th grade, 7th grade. At the time, the external backup storage is the music tape, magnetic music tape. Actually, we can use such a music tape for the backup storage. So if you, anyone who used such
This is for the cell phone.
yes. So if you turn on such the tape in the cassette tape, so you can hear the noise sound, something like that. So still magnetic tape are using for backup purpose. Why? Cheap, reliable. Don't believe your hard disk drive too much. So probably you already got the couple of experience, lose your information or the data. The hard disk drive, as you can see, it has the disk arm and spindle and rotate, and it's a stack of the very thin the disk. So if you drop or if the tip of the disk arm, the head touch or scratch, you may lose entire data. Actually, not losing entire data, but it's a logical. Physically, it hurt just 0.110001% when the head scratch the surface of the disk, but logically you lose all the data. That's the reason the hard disk drive is not reliable media. So still magnetic tape are using for backup purpose. Then the next class we will start from the storage array that will cover the SAN storage area network and the NAS network, which is server, and then disk scheduling. In the disk scheduling, we will consider only the seek time, seek the distance, which means moving forward. The comparing, there are two mechanisms. One is rotation, another one is the seek time, moving forward and backward. Which one will be slow? This one is much slower than comparing to rotation. Okay, so we ignore such a rotation latency. Instead, we will consider the seek time as the disk arm moving forward and backward. So depending on how to schedule such a moving forward and backward, so we have the different approach. That is this is scheduling. As you can guess, almost all the algorithm adapt first come first serve the disk queue, and there are several. So mainly we will discuss such a disk scheduling algorithm in the next class. Before that, we will check your mechanism. Okay, don't miss your next class to check your evidence. Any question? So as I said, regarding to your first project, today is the due date, but you can still have a time until to revise to resubmit your project until GA complete the grading, and with the GAMA will discuss, and if needed, we will have the demonstration. Okay. Any question? Yes.
For flash or pen drive, what kind of
Flash?
Flash.
Oh yes, it's kind
what
of the solid state, the disk,
Same
right?
storage.
But it's memory. It's a memory
It's not
side.
disk,
Okay. But it's non-volatile. Okay. The SSD is from the hard disk drive, but it's a solid state. It doesn't use the flash memory. It's similar. Okay. So almost the same. Any others? So we will see on Thursday. Okay. Thank you.